Greetings, cousins near and far. Welcome to my channel, Ancestral Spotlight. Thank you to everyone that has shown their support as my channel has reached its first major milestone of 1,000 subscribers. So if you haven't already, if you would be so kind as to give a like and subscribe, it would be greatly appreciated. In keeping with the title of this video, I'd like to give you an overview of the Anne of the Patawomeck DNA study, which is wholly presented in two books: Anne of the Patawomeck, wife of William Redmond and Dr. Richard Bryant, descendants of the famed or fabled Ka-Okee, a case study part 1, and Anne of the Patawomeck, lineage companion, a case study part 2, both available on Amazon. This study combines traditional genealogical paper trail research coupled with the variety of genetic genealogy techniques such as chromosome mapping and admixture. So let's dive right in. When conducting genetic genealogy, we can use multiple types of DNA testing for various purposes. In this case, we used autosomal DNA. Autosomal DNA, abbreviated as ATDNA, is found on chromosomes 1 through 22 and consists of markers we randomly inherit from both parents, made up of little snips of DNA from every ancestor that came before us, back to the dawn of our species. On a basic level, we essentially inherit 50% autosomal DNA from each parent, 25% autosomal DNA from each grandparent, and 12.5% DNA from each great-grandparent, and so forth. Autosomal DNA is subject to random inheritance, meaning that our personal genetic makeup is randomly made up of bits and pieces from our ancestors. It makes us unique individuals, unique blendings of the infinite combinations and recombinations of genetic markers blended together from all of our ancestors in time. It's why we all look and sound different. It's why siblings look different from one another and have different ethnic percentages despite having the same ancestry. They've simply inherited different bits and pieces of their ancestors. Because of how autosomal DNA is passed along, it changes, aka mutates, drastically each generation. For perspective, our mother was 100% a whole person. If we inherit 50% of our autosomal DNA from her, that's also 50% of her autosomal DNA we did not inherit. Ergo, not everyone is going to inherit genetic data from every ancestor in their family tree. Thus, everyone has two legitimate family trees. One is the actual genealogy, the other is genetic. So understand that we do not inherit genetic data from the majority of our actual ancestors. You may have heard me mention the right arm, left arm analogy in previous videos or read about it in my books. This is where it applies. You also may want to take a moment and watch another of my videos, Introduction to Chromosome Mapping. But to quickly recap, chromosome mapping, or chromosome painting, is a method used in genetic genealogy to identify which segments of your DNA came from specific ancestors. Humans have 23 pairs of chromosomes, with 22 pairs of autosomal DNA, inherited randomly from both parents. This randomness means that siblings can inherit different segments of DNA, which is why testing multiple relatives can provide a fuller picture of our ancestry. Chromosome mapping allows you to visualize and trace these inherited DNA segments back to specific ancestors, helping you understand your family history, find relatives, and fill in gaps in your family tree. By comparing your DNA with that of known relatives, you can see which parts of your DNA are linked to particular ancestors or ethnic groups, providing insights into your genetic heritage. In genetic genealogy, centimorgans, abbreviated as CM, measure the length of DNA segments shared between two individuals. Standard thresholds, often set around 6 to 8 centimorgans, are used to determine significant shared DNA. Segments of around 6 centimorgans can trace common ancestry back to medieval times, making them useful for identifying distant relatives. Lowering the threshold below 6 centimorgans allows for an even deeper exploration of ancient connections. Research by Professor Itzik Pierre has shown that by reducing the threshold to 3 centimorgans or less, it becomes possible to identify smaller, older DNA segments shared with more distant ancestors. This approach reveals subtle or ancient genetic links that might not appear at higher thresholds, providing a more detailed view of your ancestral heritage. But you need to couple this with actual genealogical research, ergo, vet each lineage of your DNA participants to verify, to the best of your ability, the common ancestor they share. This is a multiple-step process that must be adhered to so that a specific chromosome segment can be identified as having originated with a specific common ancestor in time. Admixture refers to the mixing of genetic material from different ancestral populations over time. It occurs when people from diverse backgrounds interbreed, resulting in a unique combination of their DNA in subsequent generations. In genetic genealogy, admixture analysis helps identify the various ancestral origins within an individual's DNA, revealing the percentages of genetic contributions from different populations, such as European, African, Asian, or Native American. This analysis provides insight into the complex tapestry of a person's heritage and migration patterns of their ancestors. When you overlay admixture calculators on your chromosome map, you can identify specific segments that show Native American ancestry. These calculators analyze your DNA and provide an estimate of the percentage of Native American or other genetic ancestries across your genome. By applying this analysis to your mapped chromosomes, you can see which segments are likely inherited from Native American ancestors. This helps pinpoint the exact locations in your DNA where Native American ancestry appears, allowing you to trace these segments back to a specific ancestor or family line. It provides a clearer understanding of how Native American heritage is represented in your genetic makeup. And that, dear cousins, is what we've done with this DNA study. We have identified a chromosome segment for Anne of the Patawomeck and shown that she had a mixture of European and Native American ancestry. Now, how do we prove that Anne of the Patawomeck was a descendant of the famed or fabled Ka-Okee, and thus Matoaka, aka Pocahontas? This study used a DNA-based tester, my mother. With traditional genealogical research, the line was verified as best as possible back to a woman named Jane Redmond, wife of John Grigsby. There's been a lot of dispute regarding Jane's surname, Redmond, yet oral tradition was adamant she, along with Susanna Redmond, were daughters of William Redmond. So, I chromosome mapped, at standard centimorgan threshold, my lineage back to Jane, and was able to identify, among others, a large segment alignment on chromosome 3 shared between myself, my mother, and other verified descendants of Jane, beginning with the close relatives and working back generation by generation. Then, I did the same for the descendants of Susanna Redmond, who married James Grigsby. Now, firstly, the Grigsby husbands, John and James, were relatives. I used other Grigsby lines and showed an alignment on other locations, but those from Jane and Susanna appeared to have the largest alignment on chromosome 3. It makes sense that many of the Grigsbys would also appear on the Anne segment, if we take into account other theories of William Deyo, Patawomeck Tribal Historian Emeritus, that the immigrant Grigsby took a Native American wife, but that is for another day. Likewise, I also verified numerous Redmond descendants found through the Redmond Y DNA study, and found that they also had an alignment and Native American markers on the Anne segment. This is detailed in Part 1. Now that we have a potential Redmond segment heavily shared between descendants of Jane and Susanna, who were potential sisters, we look to their parents. William Redmond, son of Anne of the Patawomeck, is the purported father. Through his mother Anne, he would have had half-siblings, themselves children of Dr. Richard Bryant. After verifying numerous descendant lineages of Dr. Richard Bryant, it was found that they too had a strong alignment on chromosome 3, the same segment found in the descendants of Jane and Susanna. This strongly suggests the two groups shared a common ancestor, which genealogical research and sacred oral tradition has identified as Anne. And when we overlay admixture, we see that Anne possessed European and Native American genetic markers. This tells us that Anne herself was of Native American descent. Next, we look at Anne. Among lots of disagreement, she is believed to have been the daughter of Colonel Henry Meese of England, who was a merchant and planter in the Virginia colony. Oral tradition states he took a Native American woman, dubbed Mary, as his first wife. There were multiple children of this union, specifically two daughters, Grace Meese and Frances Meese. Repeating the exact process as with Anne's Redmond and Bryant descendants, we found that the descendants of both Grace and Frances also strongly aligned on chromosome 3 in the same location, and they also showed Native American markers. This supports a connection between the women, suggesting that they were likely sisters, as oral tradition holds, and their undocumented mother, dubbed Mary, was probably of Native American extraction. So why do we dub this woman Mary? Are we just inventing an ancestor? Absolutely not. we can see that she existed inside the context of sacred oral tradition. She didn't have a name, so to keep her from getting lost, the various families dubbed her Mary. But let's keep going. Sacred oral tradition provides that Mary was likely a daughter of Chief Wahanganoche and a woman dubbed Rebecca. Rebecca would have been a Pettis, herself a daughter of Thomas Pettis and Ka-Okee. Thomas Pettis and Ka-Okee were said to have at least 4 children, and when we apply the same methodology among their descendants, we find the same alignment on chromosome 3 with Native American admixture. Please note that if there were no common ancestor here, they would not have a common alignment on the Anna the Patawomeck segment. Also note, this is about where we begin to lower the centimorgan threshold below standard. Now, let's take this one step further. Ka-Okee is believed to be the daughter of Matawomeck, aka Pocahontas or Rebecca Rolfe. All of the descendants of Ka-Okee are believed to make up the surviving Patawomeck tribe of Virginia we know today. If we look at Pocahontas and the descendants of her son, Thomas Rolfe, there are various well-documented descendant lines among the Bowling family. You see, Thomas Rolfe had one surviving child, a daughter named Jane Rolfe. Jane married Colonel Robert Bowling. Here is where something very interesting happens. Colonel Robert Bowling had children by 2 wives, Jane Rolfe and Ann Stith. The descendants of his wife, Jane Rolfe, became known as the Red Bowlings because of their Native American ancestry through Pocahontas. The descendants of his wife, Ann Stith, became known as the White Bowlings because, like her husband, Ann Stith was European. We find, in this DNA study, that the Red Bowlings possess the same alignment on the Anna the Patawomeck segment with Native American DNA markers, while the White Bowlings do not. Ergo, Anna the Patawomeck genetically shows an alignment via her ancestry through Ka-Okee to Pocahontas, a genetic alignment with the descendants of Thomas Rolfe, son of Pocahontas, which identifies the Anna the Patawomeck segment with a genetic connection to Pocahontas herself and to the Native American tribes of the Virginias, as various genealogical documents and sacred oral tradition provide. This is what this DNA study does. So, was Ka-Okee real, or was she a fable passed along the various lineages of European settlers that had no knowledge of one another? According to this genealogist, and proven by years of work on this DNA study, Ka-Okee was absolutely a real person in time and most undoubtedly an ancestor of the Patawomeck tribe of Virginia, and of mine. This study has been published in 2 books, Anna the Patawomeck, wife of William Redmond and Dr. Richard Bryant, descendants of the famed or fabled Ka-Okee, a case study part 1, and Anna the Patawomeck, lineage companion, a case study part 2, both available on Amazon. You'll be able to peer review my work by following along with the methodology and fully cited lineages found in the books, as well as joining the Native American DNA Study of the Virginias Ancestor Project on GEDmatch.com and the community on Facebook. For anyone that would like to support the work I do, you can become a patron via my Patreon account, www.patreon.com/ancestralspotlight, and receive exclusive gift rewards which vary per membership tier. And just a quick shout out to my patrons and followers there, you really are appreciated. Also, for those unaware, I am a genealogist for hire. You can visit my website, www.ancestralspotlight.com, or email me at ancestralspotlight@gmail.com for further details and to schedule your free consultation. I also have an Etsy shop with lots of genealogy and ancestor-related merchandise available at www.etsy.com/shop/ancestralspotlight. If you have any questions or comments about this study, please direct them to the comment section of this video or feel free to email me at ancestralspotlight@gmail.com. Happy hunting, my friends.